Seaweeds are microphytic algae ubiquitously distributed along coast from tropical to polar regions. They lack true roots, stem, leaves, and generally grow in intertidal and subtidal regions of the sea. Seaweeds have been reported as rich sources of proteins, lipids, and dietary fibers, making them attractive raw material for bioactive substances with a wide range of application in numerous fields like food, feed cosmetics, agriculture, pharmaceutical, and biotechnological sectors. Seaweeds also contain high quantities of vitamins A, K, and B12, minerals and trace elements that are essential for human diet. The demand for seaweeds and their products have been growing globally, and so has the interest in their production and the attraction of stakeholders to invest more widely in the production of various algal species that may fill different economic sector needs. All these characteristics make seaweed as a potential candidate to be researched on as a sustainable resource. India, with a coastline of 7,517 kilometers long across its coastal states and island harbors, around 844 species of seaweeds, of which 434 species of red algae, 194 species of brown algae, and 216 species of green algae have been reported from Indian seas. Different research surveys had estimated India to harvest approximately 870,000 tons of seaweeds every year. But in 2016, the farmed seaweed production from the country was only 3,000 tons, wet weight, which was less than 0.1% of the global seaweed production for the same year. The quantity of seaweed availability currently is inadequate to meet the raw material requirement of Indian seaweed industries. Expansion of seaweed farming as an additional livelihood option in the Indian coastal region will pave the way for socio-economic upliftment of coastal fishers farmers. Further, it will be helpful for mitigating the negative effect of climate change along with many other natural benefits. The Government of India is promoting seaweed farming and its related activities through the recently launched flagship program Pradhan Mantri Matsya Sampada Yojana (PM) in financial marketing and logistical support. Thus, this is the ideal moment to take seaweed farming forward in the country. To overcome all these issues, there are some pointers that needs to be considered. Number 1. To enlist and understand the distribution of the numerous seaweed species along the Indian coastline. Number 2. To understand their probable application in domestic agriculture and industrial sectors. Number 3. Carefully select the area of development for seaweed cultivation. Number 4. Develop a tool that could identify the potential of certain area-specific seaweed species which could generate a higher biomass yield without affecting the production of secondary metabolites. Available information indicates India to have good potential for seaweed culture. However, a huge gap exists between resources available and produced. In this backdrop, scope for increasing seaweed production in the country is huge, and this necessitates of active participation from different coastal states of India. Maritime Research Center has developed one such tool that can impart information nationwide with relevant and updated content, providing faster navigation, creating an impact on Indian aquaculture. For start, this tool currently has immense information about various seaweed species. There are pages that could display contents about various technologies and policies of relevance. This web tool will keep evolving in terms of introducing new functionality and more in-depth information. The aim is to develop a multifarious database of the wide variety of seaweed species available along the Indian coastline, and to help the community and industries cultivate and benefit from the seaweed species accordingly. This would in turn save time and efforts in trial and error of selection of optimal geographical location for selected seaweed species.